Now we'll do an example of modeling where we'll need to compose functions and make a composite function. Oil is leaking from an oil tanker at a rate of 2,500 gallons per day. At this rate, the radius of the oil slick is increasing at a rate of 4 miles per day. If t is the number of days since the leak began, A, create a function, call it r of t, that models the radius of the slick after t days. Let's just go ahead and start there. You might be able to just write this function down, but to help you see where it's coming from, our radius after 0 days is 0 because the leak has just started. After 1 day, well, it says the oil slick increases at a rate of 4 miles per day. So after 1 day, the radius is 4 miles. Then, after a second day, it increases by another 4 miles, so the radius is 8 miles. Let's do one more. After another day, the radius increases by another 4 miles, so the radius is 12 miles. So our radius after t days is going to be 4 times t. And if you were able to just write down r of t equals 4t, that's great. B, let's create a function that we'll call a of r that models the area of the slick as a function of its radius. And for that, all we need is the area of a circle formula from geometry, that the area of a circle is pi r squared. So the area depends on the radius. In other words, the area is a function of the radius. Now in part C, we're asked to create a composite function, a of r of t, and I used square brackets in the problem because that's what the book used, and that's fine. It's maybe a little more usual to use all parentheses, but whatever looks better to you is fine. So what is this composite function going to be? Well, we're using r of t as an input for area. R of t is 4t. And now, what does the area function do to any input? It squares it and multiplies by pi. Our input here is 4t. What goes in the parentheses, the input parentheses here, is what was in the input parentheses there, which we got from what was in the input parentheses there. And so we get pi times 16t squared. In part D, we want to use this function to find out the area after 2 days. A of r of 2, plugging into our formula for a of r of t, will be pi times 16 squared. So let's see, what's 4 times 16? 64. So we get 64 pi. This, by the way, is square miles. And we put up in our original area function too, to help us out, that that's square miles. The radius function has units of mile. So here's another place we could put in units, square miles. And let me just show you another notation for square miles, a little superscript 2. Miles times miles is how you get square miles. So that's probably an even more common way you'll see square miles written. So let's kind of get a picture of what we've done here so far. We have a function, the radius function, that takes in a number of days, and out comes the radius depending on the number of days, which we said was, what did we say, 4t. And then we use that now as input to our area function. And so what comes out is a of r, or a of r of t, which we said was pi times 16t squared. So this stuff forms our composite function A composed with R, A of R of t. That's what we did in part C. Then in part D, we put a particular number in. So we have our A of R of t function. We put in a 2, and out came a 64 pi. And because we had a formula for A of R of t, we didn't worry about what was happening inside that composite function. We didn't have to worry about the little boxes. We just used our formula for the big A composed with R box. Let's see, since this is a word problem, it's a little more usual not to have pi in our answers, but to give a decimal answer. So let's go ahead and compute that with a calculator. 64 pi equals approximately 201 square miles. So this would typically be the final answer for a word problem. Anywhere else we should put a decimal in? No, not really. Now there's one more part. Yes, there's a part E. If it costs $5 million to clean the oil from each square mile of ocean, what is the cost to clean this spill after 2 days of leakage? So, cost after 2 days, and I'm going to call that C of t, C for cost, and the problem says it's 5 million times the number of square miles. And the number, the square miles, we're calling area. So 5 million times the output of our composite function. So C of 2 is 5 million times, and we said the area after 2 days was 64 pi. Notice I'm using the exact answer here. I'm not using the rounded off decimal, because if you use round decimals, in other words, rounded off numbers in your calculations, that introduces unnecessary error. So if you can, it's much better to do your calculation with the exact values. So here we go. 5 million times 64 times, and then I'm going to use the pi button on my calculator, equals, and now I'll round off my final answer. Let's round it off to the nearest dollar. 1,005,309,649. So what's that? 1,500,309,649. Wow, over $1 billion after just 2 days of leakage. Now, although the problem didn't say anything about a composite function in part E, notice that we actually have created another composite function. Let's say I call the dollar cost per square mile let's call that D, and it depends on the area of the slick, and the area depends on the radius, and the radius depends on the length of time the leak has been happening. So our cost function was the output of all that stuff. So in this last part of the problem, we've got this giant composite function. We put length of time into the radius function. Out comes the radius. Then the area of the slit depends on the radius. So out comes A of R of t. And then the cost function depends on dollars per day. Sorry, not dollars per day, dollars per square mile. I'm running out of room here. So we feed the area into the dollar cost function. Out comes d of A of R of t. And that's what we called cost after t days. So this is a three-part composite function. And it's typical in the real world. I mean, the real world is complicated. One thing will depend on another thing, which depends on another thing, which depends on another thing, which depends on another thing. If you can get all those dependencies written down as math functions and compose them, then you can have this giant composition. So we had D composed with A composed with R of t. And if we have a formula for that, all we need to know is the number of days the leak has been occurring, and out comes our cost, which again depends on dollars, which depends on area, which depends on radius, which depends on time.